My name is Geoffrey Lessel. This is a talk about using Elixir and Scenic UI to create an external steering wheel display for simulator racing. And of course, this could probably be taken further to do real racing as well if we wanted to go that far. But we'll start with sim racing. So I found this was an interesting topic, and there's some interesting things we're going to be covering in this talk. The first is we need to open ports to listen to UDP packets. So we'll go over how to do that. We're going to capture binary streams and parse all that. So we're going to use pattern matching for that, which is kind of cool. We're going to be using gen servers. We're going to use a pub sub mechanism. We're going to be using Scenic UI. And all those things together are going to be pretty neat. Now, in the past, I've done some talks that are more kind of tutorial-ish, how to do specific things. This is more of a talk of something fun I did, and more, not really a show and tell, because we will be looking at some code, but more along those lines than a live coding type of simulation deal. So just to let you guys know. But I think it's probably a good topic for the first session of the day. Nice, easy one to ramp into ElixirConf. So I love Formula One, and past that, I love Formula One steering wheels. When I started watching Formula One back in 2007, I guess it was, my dad had watched Formula One for a while, and we had moved back to where the hometown that I grew up in, and started watching Formula One with him. And like any sport, you don't really get into it unless you start really knowing the characters in the whole opera of the sport. So I started, liking a driver and wanting and rooting for him and enjoying the races more and more. But as they were going around the track, it was fascinating to me that they had this steering wheel with all these knobs and buttons and controls and all sorts of stuff. And I love knobs and buttons and controls and fiddling things and watching people kind of have mastery over a machine like that is very, very fun for me. The problem with Formula One steering wheels in particular and other racing steering wheels is a lot of them, well, all of them are proprietary. So the teams come up with the steering wheel. There are some restrictions around the kind of designs they can have, but they're pretty free to come up with how they want to implement their steering wheels, and part of that is the displays. So back in 2009-ish, this is an example of a steering wheel from like 2009. This is from the BMW team, which no longer exists. And this one's a semi-complex one. You can see, I'm sorry for the bad quality of this image. It's amazing how hard it is to find pictures of steering wheels in Formula One, just as an aside, because they're so proprietary and people want to hold on to their secrets. But anyway, you can see there's a lot of knobs and buttons, and each one of those rotary dials, you can take it to a different position, and every one of those buttons probably does something completely different depending on what position that rotary dial is in. And then you can see the display at the top is basically just some LEDs or LCDs. It's pretty minor, pretty minimal. It kind of displays the position you're in, maybe the lap you're on, maybe the speed you're going, maybe some information that you have to memorize certain codes. But of course, as Formula One has progressed in its technology, the steering wheels themselves have also progressed in their technology. And as you can imagine, now we have kind of built-in screens on the steering wheels. This one's probably from a few years ago. I couldn't find an exact date on this one, but it's kind of a chunky one. It does still have a lot of rotary dials and switches, but now at least it gives the driver a little bit more feedback as to what they can see. And again, it's hard to find a picture with the screen actually on. However, here's one. This is an old Mercedes steering wheel, probably from last year, maybe 2 years ago. It's monochrome at this point in the development process. But every team can determine what they want to show on their screen at any time. And even each driver can decide what information they want on their screens to help them drive better, make decisions better in terms of during the race, maybe different phases of the race, they want different information, that kind of stuff, which is kind of neat. And this is last year's Mercedes steering wheel. And again, the screen's just getting bigger and bigger. The knobs and buttons are kind of getting smaller, a little more compact. You can tell that that middle rotary button especially has a lot more spots to put the dial in, so that you can control a lot more things with fewer buttons because they have the extra feedback of the screen itself. This is an image of a screen that was taken in the pit, the garage. So he's not moving, but cameraman was able to sneak a shot of that in there. I think it's pretty neat, see all the colors and all that. So this kind of stuff fascinates me. And here's something that Sauer put out, the Sauer team from 2014. This is their 2014 steering wheel, and it kind of goes over a little bit of what each button is supposed to do. Obviously, it doesn't go into details of how it does it or different specifics of those things, but it's pretty neat. So if you want to see that in detail, I can forward that to you, but we're not going to cover it all right now. So during a lap of a Formula One race, you may be wondering, well, why do they need all that information? Aren't they just driving a car around the track? And in some senses, yes, and there's some racing purists that wish it was still just the steering wheel like you have in your car, even probably steering wheels from the 50s, where it's just like a wooden wheel, and you just turn the wheel, and that's all you need to do to get around the track. There's some racing purists that wish it was like that, but really the Formula One cars these days are huge computers that are processing information at incredible speeds and providing feedback both to the guys on the pit wall and also to even hundreds of miles away, thousands of miles away in their home base, and they're constantly feeding back information about what to do during the race. But anyway, during one lap, the driver has a lot of things to do during one lap. For example, in a track like Monaco, which is really the shortest lap on the circuit, there's 41 to 57 gear shifts in one lap. There are 19 corners in this particular track, 8 rotary switch changes during one lap, on average, of course. They obviously have to read the dash. A lot of times the guys on the wall are asking the driver what the dash is saying, and you'd expect that if you're going 200 miles per hour down a city street, basically, with walls on both sides, you want to be looking at the road and holding on as tight as you can, but these guys have to look back and forth from the display to the road, which is insane. And they go 2 miles in 1 minute and 14 seconds. So all that in 1 minute and 14 seconds over 2 miles, which is insane. So that means over one race at Monaco, for example, there are 3,600 gear shifts. That means one shift every around 2 seconds, which is a lot of gear shifts. There's gigabytes of data being sent to and from the car. There's sensors all over the place on tires, on the engine and exhausts, on the forces the suspension's doing. Even the driver itself has all sorts of sensors that they're monitoring heart rate and that kind of stuff. So there's a lot of information being passed to and from. And one question would be, well, why do they need all that information if they're just going around the track? And a lot of that has to do with the setup of a Formula One car, or any racing car, really. So our kind of street cars are set up to where it's kind of an average. So if you can drive a car, you're not going to run this thing off the road unless you're doing stupid stuff on it. It's pretty, bouncy, and there's obviously some variation in that. But it's typically made for normal people to drive around the track just fine. Whereas a Formula One car, there's particular corners you need to enter the corner in a certain way, and then in mid-corner you need the suspension to act a different way, and then as you exit the corner, you need to do something completely different. And so the importance of setup is huge. And so, for example, in sim racing, they're trying to do these exact same things. So this is an example of a simulator called iRacing. It's an online simulator. It's only online. It's probably one of the more complex simulators out there. But this is the setup screen for one of their cars. And every one of those little arrows back and forth, or a place you can type in numbers, is a different thing you can control on the car to help you get around the track faster. And there are people who spend hours and hours and hours trying to get the exact setup for a particular track to make them the fastest. And in fact, there's even been an industry that's kind of sprung up around selling these setups and selling subscriptions to guys who just happen to know how to set up a car very well. They'll sell the setup for that week's track. And of course, the driver themselves can go and modify that a little bit if they need to, based on their preferences. But there's a lot of information that you're required to set up this car. And a lot of it can be changed inside the car. One of the screenshots I don't have on here is iRacing in particular has the ability to control most of these things, depending on the car, a lot of these things based on buttons. So you can have button boxes and buttons on steering wheels and all sorts of stuff to change all these settings as you're going around the track. This is the steering wheel I use on my setup, my racing setup. It's modeled after a Formula One steering wheel, and you can tell it's got a lot of buttons, and that's what drew me to it, as you know, because I like buttons and switches. I was very sad that these weren't actually rotary dials, but I've seen people modify this to drill these out and make them rotary dials so that you can control all these different things from your steering wheel. And of course, it's got the paddle shifters in the back, which makes such a that's a great noise. So this is fun to use, but there's also some things you can do apart from that. So people have button boxes on the side where they're flipping switches and modifying things. There's even people who have, like when you're going around the track, if there's a wreck in front of you, they'll do a yellow flag, which means watch out, slow down, you don't pass anybody. because there's an accident ahead. And some people have external monitors for those. All they do is flash yellow when there's danger ahead. So all that stuff uses APIs from these games. And what we're going to do is we're going to tap into one of those APIs, in this case Formula 1 2018 from Codemasters. It's both on PC and on different consoles. And this particular game there's a range between arcade racing games, and simulator racing games. Arcade games are, you don't have to know anything about cars and just press go, and like kind of Mario Kart, even if you don't press anything, you can set a setting to where it'll take you around the track itself, and my 3-year-old can do it, and it'll just do fine. But there's other games, simulators, where you and I, if we get in it and we're not used to it, we'll just spin the car the first time we sit on the accelerator. They try to monitor or try to simulate every little thing of the car, as you can tell based on those setups back there. But Formula 1 2018 is kind of in the middle between arcade and simulator, so they're trying to simulate the physical world, but they're also making it fun. They want to allow Formula 1 fans to come in and buy this and enjoy racing with their heroes or idols or whatever. And probably more on the simulation side of things. So it's not as simulatory as something like iRacing, or there's another game called R Factor 2 that's pretty simulatory. I don't know if simulatory is a word, but I just made it up. So there's those on that side, and then there's Formula 1 2018 kind of below that in the arcade side. But I will say there's a driver named Lando Norris, and he started driving this year in Formula 1, and he's one of my favorite drivers because he has a Twitch channel, which is really cool. So he plays F1 2018, he plays iRacing, he's online doing races like this, but he did that for a long time before getting into Formula 1 this year. And so I've kind of been able to follow him. Probably a year and a half ago I started following him, and was super excited when he finally got a Formula 1 drive this year, because I've been able to see him progress and get better in simulating racing and all that. But this is his particular setup at home. So when he gets home from a race, these guys have crazy schedules to begin with, so they're flying all the way around the world, and he gets back home on Monday after a race on Sunday, and he fires up Twitch, and he goes racing again, which is really cool, because you can go on there and chat with him, and he's answering questions, and he's just kind of a down-to-earth guy, which is why I really like him. But seeing that even Lando Norris uses F1 2018 to kind of get to know the track before he goes to it, tells me that it's simulatory enough for me to be able to enjoy it and think that I'm getting there, I'll never be a Formula 1 driver, but at least I can use the same simulator that Lando Norris does, at home at least. He's also got like a hundreds of thousands of dollar one at the McLaren headquarters, but that's a different story. But you can kind of see he's got his own custom steering wheel there. He's got some external displays. He obviously has a three monitor display. He also has another one on top so he can monitor his Twitch streams and all that. But you might also ask, well, what do we can use this information for? One of them is motion rigs. This is a guy kind of went to the extreme, built a 6 degree of motion rig. He's obviously not just doing he's not doing Formula 1. This is like some sort of rally race or something. He's going over some bumps, and you're not going to do that in a Formula 1 race. But you can do this with some of the information provided by some of these APIs. It tells you the state of the world, what the car is doing, the forces that the car is going through, and all that. So you could build one of these if you wanted to. Another is broadcast graphics. I had mentioned that iRacing.com was on the simulator side of things, and they actually had, just like I think 3 weeks ago, had a broadcast with NBC Sports Network, a live broadcast of a race online. And this is what they used. This is their broadcast graphics. And they pulled all this graphic information, I'm sure, from the APIs that iRacing provides to provide like actual broadcast graphics, which is kind of neat. Yeah, I'll say that. Okay. Then the other thing is HUDs. So heads-up displays. Twitch streamers kind of use their own special things. This is one of my favorite Twitch streamers, Matt Malone. And you can see like on the top left there is kind of the timing of everyone around him, how far away, how far behind people are based on his laps. And there's other displays as well that show information, mostly for Twitch, like there's chat and all that kind of stuff. But you can use these APIs to provide things like that. And of course, while we're all here, F1 steering wheels, right? So this is, I mentioned that it's really hard to find a good shot of a Formula 1 steering wheel display. But there are a couple of night races every year. And during one of those night races, I paused the feed, the broadcast, every time an onboard shot of a driver was going. So I could take a screenshot of their Formula 1 steering wheel so I could see kind of what they prefer and how they have their things set up. And that, of course, that means the quality is horrible, but you can kind of get an idea. But even among different teams, you can see different teams do different things. Most of the teams have the display inside their steering wheel. Some of them have this display beyond their steering wheel, so it doesn't add to the weight of the steering wheel itself. But even among the teams themselves, there's 2 drivers per team in Formula One, and each driver has their own preferences for what they want to see. But it's kind of interesting, like Max Verstappen, who, if you look on the second row far left, that's his steering wheel. He has very little on his steering wheel. So it basically just has the gear number, which he's in gear 7 right now, kind of a delta, which shows the difference of time between that and some other reference time that he has set up, and the status of his battery, because Formula One cars are hybrid electric vehicles. So that's kind of minimal. And then you've got Sebastian Vettel, who is on the top row, kind of third one to the right. He's got all sorts of weird stuff. He's got like some sort of inverted ladder thing going on, and all sorts of information. To me, he's kind of like the professor of Formula One. He seems to love all the details. So I imagine that he's looking at that as he's going 250 miles an hour down a straight and being like, oh yeah, okay, that's good to know. Whereas I'd be screaming in my seat. He's looking at all these numbers and trying to figure out what to do next. So in order to accomplish this, what do we need to do? The first thing we need to do is we need to get the data stream from the game. In this case, again, we're focusing on F1 2018. And thankfully, they provide an API for this. They have a developer forum where they kind of post the specs for all these things. We'll kind of do a brief overview of what those are. Then we need to decode those binary streams into something that we can use in Elixir, which is going to be fun. And then we need to publish that information to different things that are listening, so kind of like a pub/sub mechanism. And then make a gen server to listen to those changes and update its state, and then have Scenic refresh itself at a consistent rate to grab the current state of the world that it knows about and put that display on the steering wheel, the things that we care about. So let's cover these in a little more depth. So getting the data stream from the game. The game has a setting in the menu for telemetry, and so you can turn on UDP telemetry, which is just a simple setting. It's interesting, they provide 2 different modes. One is you can specify an IP address that you want all those packets sent to. So you can say, I want it sent to my computer, or I want it sent to this particular display if you have it actually externalized. Or you could just bark from all over the network, just broadcast them without a specific recipient indicated, and whoever wants to can pick them up and use them. It also has the ability to set the frequency that these packets are sent. Some of the packets are at a fixed frequency, and this setting won't mess with them at all, but there's others that you can modify this. So the fastest you can get it is 60 hertz, which is 60 times per second. So as you're driving around the track, you'll get an update, a UDP packet, actually multiple packets, 60 times every second, which is enough for plenty for what we're going to try to do. All right, so here is what the developers of F1 2018 provided on a forum post. And we're not going to hit a lot of these details, but we're kind of hone in on a few things that we're going to find interesting in this. So they provide all the structures as kind of C, in a kind of a C language, in C structs. But you can see that they identify the different bits. So for example, let's take a look at this packet ID one. It's an unsigned integer with 8 bits. And so knowing that, we're going to expect that when we implement our Elixir decoder or our parser. But this is the header packet, and so these are all the things they send in every single packet. Every single packet has a header with all this information in it, including this packet ID. And you see the table down at the bottom are the different ID types. There's some of these packets we're not going to care about, or at least I'm not in my steering wheel display. And there's some that we're really going to want to dive into. So there's things like the motion data, the session data, and we'll get into some details about those here in a second. Then probably the most important thing is the player car index. So as these packets are sent out, most of them will have an array of information for every car that it knows about. And in that array, we're going to need to know which one is us. And so this provides the index within that array of which car is us. So we can use that to really hone in on the information we want. So this is the car motion data. That motion rig that I displayed earlier, this is probably using something like this. So this is the state of a car's G-forces, basically, the forces that are acting on the car 60 times per second as it's going around the track. So it's got the position in the world, it's got velocity in the world, different G-force components, which is pretty cool, the pitch angles, the roll angle, all sorts of crazy stuff. So that's provided for every car in the simulation. As you can see here, this is the packet motion data packet. You see it has the packet header, but then it has an array of 20 of those car motion data structs that I just displayed. So for every car, there's 20 cars on the track at a time in 2018's Formula One regulations. And so for every car on the track, you're going to have all that information. Now, why you need to know the lateral G-forces of someone 5 cars back, I'm not sure. But you could use it and It'd be kind of cool to maybe create a whole room of things that are moving around you as you're driving. I don't know. I don't know why you need it, but they provide it, which is kind of cool. But then for the player's car, you can see at the bottom, they provide for some extra player information, which is also kind of neat. So you can have even more detailed information for your particular car as it's going through its motions on the track. Oh, this is every header has this, it's going to be like this. We're going to see that pattern repeated a lot. Okay, so in the packet session data, we're not going to need a whole lot of information in this one. One interesting thing to note is the marshal zones. As I mentioned earlier, there are those yellow flags as you're going, and there's that external yellow flag presenter that someone has made. And that probably uses information like this to know where along the track the marshal zones are, which marshal zone the player is currently in, and the different status of those marshal zones as he's going forward. And a marshal zone is basically marshals around the track who are in charge of a specific portion of track and waving flags based on the status of the track that they're in charge of. So they're in charge of waving the yellow flags and stuff. All right, the packet lap data. This one is actually going to be the one that is kind of most important for what we're going to be implementing here. And in here, we've got 20 different of these structs. We've got the header, and then we have 20 of these lower structs. And things we're going to be shooting are the lap times. I like to know the different things that are going on for the lap. Like, I like to be consistent. Consistency is key in racing. And so I like to know what my last lap time was, what my best lap time was, what my current lap time is, and maybe the difference between my current lap time where I am now in the world versus somewhere in the future, or sometime in the past, rather. And that's what should be with lap distance. So if we know the current lap time and our current lap distance, we can look through past history and find another lap where we were that far through the lap in history and the current lap time there, and compare our current lap with that one. So we say, if I was 1,500 meters through a lap now, and it took me 1 minute to get there two laps ago, but now it's taking me 1 minute and 5 seconds, I know I'm 5 seconds behind where I was 2 laps ago, so I need to kind of pick it up. Another thing that's interesting is the current position of our car and our current lap number. So these are going to be important because those are good things to know as you're going through the track. That's really all we're going to need from that packet, which is not a whole lot. This is a very small packet, the packet event data. This just is whether or when the session is started and ended. And so you can have a listener for that to actually start updating your display, whether it started or ended. The participants data, this is basically other information about the drivers. These races can be online, so some of this information can be drivers from around the world, their names and nationalities and things like that. You can display those. In an esports broadcast that Formula One did for Formula One 2018, they did provide some things like the player's nationality flag, for example, on their broadcast information, which you could use for this. And then packet car setup data, if you wanted to steal your opponent's setup, you can do that here. It provides all the information about how they set up their car. The Formula One 2018 setup community isn't as protective as things like iRacing. In iRacing, honestly, there's like tens of thousands of dollars of prizes for a season. So the winners of the seasons can get upwards to $100,000 of prizes. So they're very protective of these setups. And then car telemetry, this is another important one. One thing that I'm not going to highlight here in a second, but that is important, is we can detect within this status different button presses. So there's another table that I didn't include in the slides that says which button is being pressed. But we can listen for button presses through the API and use that to change our display or update it in a different way or anything like that. So there's different stages of a weekend. You have practice, and you have qualifying, then you have the race. And you may want different information during the qualifying session than you want during the race. Or you may want something different in the race start than you want in the race end. So you can use those buttons to update your display based on the situation of the race. We have our speed in kilometers an hour. We have what gear we currently are in. These are all integers. So reverse, for example, is -1. Then we have our DRS. It's basically a flap in the back that opens up in the rear wing to make you go faster over the straights to help in overtaking. And then we have the car telemetry data. We're going to kind of breeze through these a little faster because there's not a whole lot in here we need. But there's things like how far we're pressing our throttle, whether the clutch is in, how much we're pressing our brake, the location of the steering wheel in radians or degrees or whatever, the RPM of the engine, those types of things. And finally, but we have the packet's car status data, another interesting one that we're going to be dealing on because we have the fuel mix. So during a race, the driver can determine how much, or the mix of the fuel based on the oxygen levels in the fuel as it pumps into the engine. So that can make the engine run faster, but also makes it run hotter and harder. So during the course of the race, they have to monitor this because there's a certain amount of fuel they can use during the race. So they want to make sure they don't run out of fuel during the race because they can't refuel. So that's important. And then the front brake bias, you'll see if you watch a Formula One race on the on-screen shot, they're adjusting these every third corner or so. So how much the front brakes grab as compared to the back brakes. So in some of these, you want the front brakes to grab harder than the back ones, and in some cases, you want the back ones to grab harder than the front ones. And so this is dependent really on the corner based on the driver's preferences and the car setup and all that kind of stuff. So this has changed a lot in a real race. And then also we have the ERS, and this is the energy recovery system. I mentioned they're hybrids, so this is basically the status of the battery, whether it's capturing energy, how much it's captured over their lap, and when it's putting out energy, those types of things. And then we have, well, that's actually the last packet that we're going to be looking at, and that's the last packet they provide in last year's version. So now we need to decode all that, right? So we have all that coming in through UDP, and we'll look at code here in a second that we listen for that. But one thing I'd always heard is Elixir is good at binary, right? And pattern matching is amazing for binary. It's like, well, okay, I hear that and I can internalize it. Yeah, that's interesting. But until I actually started implementing it, it wasn't that interesting. But now that I've implemented it, it is really, really cool the way it works. So let's look at it in some detail. So this is the telemetry listener. So this is something I've created. And again, this is a project of mine that was just kind of fun. So some of this code is not going to be optimized. It's probably not the best way to do things. Some places may not even be the best place to put things, but it works for me, and I'm continuing to be good on it, or to make it better. So this is the listener. The first thing we're going to need to do in this is it's a gen server. We're going to need to open up the UDP socket, and Erlang has some functions for doing this. And we're opening this specific port, and in this case, the default port is 20,777. So it opens up that port and listens for UDP packets, and we're expecting them in a binary format. That's what that's basically telling us. And then we're going to initialize a state with a list of listeners. So I mentioned earlier we're going to have kind of a pub-sub thing going on. In this case, we're going to have no listeners to start with, but we're going to allow a mechanism for other processes to register themselves with this listener and say, hey, I'm interested whenever you receive a new UDP packet. So that's where they do this. They call register. Past that, we have the handle info. So whenever the gen UDP function gets called, it sends a UDP information message to the gen server that's running. And so in this case, we need to handle that. So whenever we get a new UDP packet, we need to, it calls this function here. And in there, we're going to parse the data. We're going to grab it from the packet stream, and we're going to parse it. And so in this case, if I have, I've made up a 3-element tuple, basically, that I'm expecting to receive back in my parse functions for each particular type of packet. If we get that back, we're going to send it on to our listeners. If we don't, then we're just going to return OK. We don't really care about it, and that way it doesn't error out. So in this case, we're going through each of our listeners and sending the parsed data from the parsers. And we'll look at the parsers here in a second. All right, here is an example of a parser. This is the main parser that handles all the other parsers. So whenever the data comes in, it gets sent to this particular parser. And you can see here the pattern matching is started. I'm going to bring that in just a little bit. So on the right is the information that the developers provided. And on the left is the implementation of the pattern matching in Elixir. And some of these, you can see on the left-hand side there, I have format, and it's a little unsigned integer with 16 bits. That's what those mean. And it's going to pattern match that into a variable named format. So this is the format we're expecting for this particular packet. In this case, it's always going to be 2018 because that's the version basically we did this for. We have the packet version itself, and then packet ID, session ID. But I've matched each of those C types to a kind of a long form version of the Elixir types on the left there. And some of these are defaults in terms of the pattern matching, but I prefer to be explicit in what I'm expecting so that I don't rely on those defaults, but I say this is I know I want this in this particular format. So once we have that, you can see the very bottom one of those is rest, and we're expecting it just to be binary. So past that, the first of those is the header. And so we're going to parse out all the header, and the rest of it is we don't know quite yet. It depends on what that packet ID is. And once we do that, we have this header struct that we pass through, and we parse the rest. So once the rest comes through, we can know how we're going to attach that header and return the rest as well. And the rest is down here, so we parse all these. So this is pattern matching, again, at its finest. And for each particular packet ID that we have, we're going to send it to a different parser. So you can tell, I mentioned earlier that there's some packets that I don't care about, like the motion data. I don't have a motion rig, so I haven't implemented that yet, so I just ignore it. But for example, let's look at packet 2, which is the lap packet. We know that the packet ID is 2 based on the header, and so we're going to send that to lap.parse with the rest of that data that we have. So let's look at that. So the lap header, or the lap module looks something like this. As I was implementing it, I basically just copy-pasted the C code that the developers provided and used that to help me in the pattern matching on the Elixir side. So you can see that as the top comment there, just a whole basically explosion of C. And then past that, though, we have our struct definition. And I initialize everything with sane defaults of 0, clear it out so that once the display starts, it'll display something and not crash. Because if it tries to display like a null, then that's not going to really work. And then here's our parse function. And again, we use the binary pattern matching to pull out exactly what we need to in each of those. And as you remember, the whole packet has that header, and then, for example, for most of them, an array of 20 different of these packets that are, in this case, lap packets for each of the 20 cars on the course of the time. And so we're going to use recursion to go through each of those until we don't have any more rest in that binary, so that we can get each of those packets into the state that we're going to pass on to the listener. And then past there, this is where we return or do the recursion. So we set up the module. In this case, it's the lap module with the struct that we provided, and then we're going to parse the rest. And that's where the recursion goes. Once we get to the end there, it's going to parse nothing, and it's going to return empty list. So now that we have that information, we need to publish that received data. And that's, again, that pub sub stuff. And since I looked at the pub sub, we're going to look at a different listener. So I have that F1 game telemetry module that I separated from my display module because things are starting to be a little too tied together, which is why I made the pub sub mechanism. So this is on the display side. We want a listener for those different things. And again, it's a gen server. It also uses Scenic. This is the first time we're seeing Scenic enter the scene. Sorry, that was not intended. But Scenic is now here. And Scenic has an idea of sensors. And sensors, you may not think of Formula One telemetry data as a sensor coming through UDP packet, but a sensor is really something that is being monitored that needs to, the Scenic needs to know about to update its display state. And so in this case, we're registering these different sensors that we care about. We're going to care about a lap, we're going to care about telemetry for the car, we're going to care about a session, and we're going to care about the status. So we're basically registering those sensors so that Scenic knows that those are things that, on the back end, it actually implements it kind of like a pub sub mechanism like we implemented earlier. So we're registering those and saying, set these up, and it's going to have no listeners right now, but it's going to have these names. You can also see, let me go back actually. So at the bottom there, we also register ourself to the F1 game telemetry module, so that pub sub mechanism we set up earlier in our own module, we now have this as a listener. Now, whenever that F1 game telemetry module gets a packet, remember it sends it through parse and then sends it to all its listeners. And so we need to do something when we receive one of those packets. And so here's the F1 game telemetry info, the handler. So we have the F1 game telemetry. It kind of identifies itself as the thing that's sending it to us. And we have the type, the header, and the data. 5 minutes? Okay. And then the state. So we publish that to our sensors. And I need to go a little quicker here. Do I have more than 5 minutes if I don't take questions?
Yeah, I
Okay. All right. So we publish that to the sensors, and then Scenic can do what it needs to with those sensors. Here is an example of the lap store that I created, and this is where we store all the information for the laps that we receive from those sensors. You can see we initialize it, we subscribe to that lap sensor, so anytime that sensor publishes a new lap, we'll receive that information, and of course we'll need to handle that later. But we can see here we set up kind of an initial state of things we want to care about on a particular lap. And then here's the handler. So Scenic will send this particular structure of data to you, to a handler. One is, first it says sensor, and then the name of the sensor. In this case, it's, sensor, then the data, and then the lap is the first thing in the tuple that it sends. So it's got a specific thing that it sends, so we need to listen for that specific thing. So first we find our car, and again, remember I said that every header has the index of the player's car. We need to use that index to find our car, because that's what we care about. And then I've got a lot of code in here that's kind of ugly that basically checks on the lap statuses, whether we have the fastest lap of the session or whether we have a new best lap or all that stuff. But we basically go through all that and then return the new state with that new lap in it. And then this is the more handlers I have that basically just returns data that we may find interesting in Scenic for the different displays we're going to be implementing. So this is basically mostly just getters. So let's get to Scenic. So we're going to use Scenic UI to create the display. The first thing you need to do is configure it, right? So I went through, and Scenic has the idea of a set display size. It's kind of behind the scenes implements OpenGL, I think it is. And so it needs to know how big of a thing to draw, right? How big of a screen to draw. In this case, I went through and looked at different external screens to see what a good resolution might be if I ever wanted to take this outside of my computer and put it on an actual screen. And based on price and availability, 800 by 480 was a good size. So I said, this is going to be the size of my display. And it's not going to be resizable, and it's going to be called F1-. So this is the configuration for the Scenic part of things. Here is a scene. So Scenic has an idea of scenes, which is basically like a type of display. So if you had a scene that displayed your tire temperatures, that's all they want to display, you could just have that as a scene. Then you can go back to the main scene that displays all the rest of the information, things like that. You can change scenes around. But how you build a scene in Scenic is you create what's called a graph that basically describes how you want that scene to be created. And so this is us creating our first initial graph. So it's building the graph. I'm using this particular font. You can use custom fonts in Scenic. It's a little bit fiddly, but you can do it. And then we're going to pass it to these particular components. In this case, I have a lap counter component that I created, and we'll look at in a minute. And we're going to add that to our graph. And this is just going to pipe the graph through all these different components. We're going to add the lap counter to our graph. It's going to be initialized with 0, 0, and we'll see how that's implemented here in a second. We're going to give it an ID of lap counter because we're going to need to reference it later when we want to update it. And the translate basically says which pixels on where we want to position this particular thing pixel-wise on our display, on our 800 by 480 display. It also Scenic also has the idea of primitives, which is basically something that's never really going to change, or even if it is going to change, it's not something that you need to create yourself. Things like rectangles and text and things like that. So there's also primitives. So in this case, I just have last, which is going to kind of label our last lap. So we build all that, and then we, in the same module we initialize, we're going to subscribe to those sensors, because we also want to know when those sensors are updated. And then we're going to build the graph, send a timer. So every 100 milliseconds in this case, we're going to send the timer back so that Scenic's always updating itself every 100 milliseconds or so. And for our cases, this is fine enough. I've taken it down to like 24 milliseconds, which was overkill, but it handled it okay, which is interesting to know. So then we set up our graph, and at the very bottom there you can see push graph. So we're going to push the graph to the display, and that's what finally updates the display with our new graph. So we built it, and then we need to tell Scenic to actually go and do it. That's that. So let's take a look at some more info. So whenever our scene handles or gets information from our tick, we set up that interval, that tick interval. This is a tick. So first of the thing it does is it finds our particular statuses from our states, our gen servers, with the player car index that we provided earlier in that header. We're going to get all that, then we're going to update our graph. And this is how you update a graph. You're going to take that initial graph that we have in our state, so what the current state of the graph, and we're going to pass that through graph.modify, and then the ID of that particular component. So remember earlier we had the lap counter ID set up, so this would be it would be graph.modify lap counter, so it would know which particular component to update. And then it would have an update function on your component that it would call. So let's take a look at that here in a second. More info handlers, we'll pass that for time-based sake. So here's our lap counter component. It's pretty small, but this basically tells the lap counter how it should present itself and how it should be updated and verified. So you can see here it's got a verify function, so you have to provide this. So given the inputs that you've been given, can you provide a functional screen for this particular component? And that's where we say, okay. And if that's the case, then we initialize with this particular graph. So you can see here I'm just building a new graph, which is what each component does, and have a text primitive that has L, and then the current lap, and then a slash, and then the full laps. So L is my lap counter text. And then our update basically takes the new information we receive and updates the state through this. So what does all this look like? I've modified this as I've gone through and tried to figure out what I wanted to display. This is one of the implementations, so you can see that last and best, the primitives over there on the right-hand side. So those are my different times. So my current time is on top there, and then my last time and my best time. And then my delta on top there, which is basically how far or ahead I am in my current lap based on some previous lap. In this case, it's my best lap. So I'm always trying to get my best lap. And then on the left-hand side, top left, we have my current position. So right now I'm P1 leading the race. Actually, this is a practice because of my lap counter. I'm on lap 4 of 99. And 99 basically is F1 2018's way of saying you're in a practice session because there's no limit to the amount of laps you can have. And then down at the bottom is my energy harvesting. So I mentioned earlier, it's a hybrid. So this is basically the state of the battery as I'm going through. So I'm trying, this is another shot of a steering wheel in a garage. And so I'm trying to use some of the same colors and positions of things that like a real Formula 1 driver might use. In this case, he has his gear indicator smaller than probably I would prefer it. And he has some of his energy stuff that honestly, I don't care that much about as much as some of these Formula 1 drivers do because they have to manage it a lot more than I might have to in my simulator. So I took a little video. This is the current state of what it looks like. So on the bottom there is running on my laptop, and then on the top is me driving it. And I'm not driving it with my wheel. I'm actually driving it with a controller on the Xbox so I can make the video easier. But here it is overlaid with the current view of the particular screen that I've got going on. So I apologize for the controller driving. It's not a great lap, but it indicates what's going on. So some interesting things to pay attention to. I've made the gear change a little larger because that's very important to me. And at the bottom, I have the energy harvesting. So you can see that as I press the brakes here in a second, you'll see that start to grow. So I'm using energy right now, and then as I press the brakes right here, it'll start to go up again. So you can see me harvesting here. So I'm getting more energy there. Right now, I'm 0.3 seconds up on my best lap. I'm currently in P5 based on my last time. And you can see my last time, my best time, and then what lap I'm on there. So that's kind of how it works. Some next steps here. First is I need to open source the UDP parser. I did that. It's a GitHub/Geoffrey/F1 game telemetry. Update it for F1 2019, so the new version of it. We need to port the code to nerves and actually make an external display and allow easy, particularly maybe GUI-based, make it to where you can customize it yourself. All right. I made a book, Phoenix in Action. It's on sale right now. Here's a code. Write it down quick. 40% off anything at Manning for the weekend or while we're here. And I had a book signing at lunch. The hotel has lost the books, so we'll not be doing a book signing at lunch. Hopefully they're going to be here tomorrow. So Manning overnighted another box of books. So if you want one, come see me. I'd be happy to give you one. And I have some free codes too. So if you want a code, come see me. I'm Geoffrey Lessel on Twitter. Thank you guys.
Thank you.